Namaste students. In the last class, I taught you some tricks about how to find the square of any number. I hope you all have enjoyed that tricks, yes, and you have solved some other problems related to that. Okay, so the last method which I taught, it was too easy. Yes, all the three were easy. So last method it was applicable, and it is applicable for all the numbers from 1 to 99. Okay. So now in this session we are going to deal with some other numbers and how to find if a given number is not a perfect square. When a given number is not a perfect square, if you multiply that given number by some other whole number, we are going to get a perfect square, isn't it? Yes. So some questions are there from your exercise. Find the smallest whole number by which the given number should be multiplied to get a perfect square, and also find the square root of the given number. Yes, what is that? Find, that is in I think 5.3, 5th or 6th main questions are there. Find the smallest whole number by which a number, yes, a number can be multiplied to get a perfect square. Okay, we will deal with I will take some numbers and you will understand. Find the smallest whole number by which the following numbers can be multiplied to get a perfect square, and also find the square root of the new number. Yes, the question is as follows. Find the smallest whole number by which the following numbers, I am going to take some numbers now, can be multiplied to get a perfect square. Yes, by which smallest number, if you multiply a given number, you are going to get a perfect square, and also find the square root of a given number. Okay, now let us take a number as 252. Okay, is 252 a perfect square? See the number, is it a perfect square? No, it is not. Why 252 is not a perfect square? Because it is ending with 2. Yes, some questions are there like this in the last exercise. Is 256 a perfect square? 252. 252 is not a perfect square because it is ending with 2. Okay, that's the answer. Now, we know that this is not a perfect square, but if you multiply 252 by some other whole number, we are going to get a product. That product, it becomes a perfect square. That we have to find, and also we have to find the square root of the product or the new number what you are going to get. Let us find it. So, how to get the answer? 252 is there. We have learnt the prime factorization. Yes, let us do it. So, the given number is 252. The condition for finding the square root is what? Whatever the prime factors you are going to get, those should be paired. They should be paired, right? They must be paired. But for the non-perfect square, you are not going to get a whole number as paired here. Okay, let us see. 252, it is divisible by 2. 2 1s are 2s are, yes it is, 2 6s are 2, 6s are 2 3s are 63. It is not divisible by 2, it is divisible by 3. 3 2s are 3, 1s are, then 3 7s are 21. Yes, then 7 1s are 7, isn't it? So now if you observe this 252, what are the prime factors you got? Therefore 252 is equals to 2 into 2 into 3 into 3 into 7. 7 1s are 7, 3 7s are 21, 3 21s are 63, 2 63s are 126, 3 126 are 252. That's what we wrote here. Here if you see 2 and 3 are paired but 7 is unpaired, isn't it? 7 has no pair. Therefore, 7 is not paired. Therefore, 7 is not paired or unpaired. Yes, 7 is unpaired. Therefore, that implies 7 is the smallest whole number by which 252 should be multiplied. Yes, why it should be multiplied? It should be multiplied to get a perfect square. Yes, let us see which is that perfect square. Okay, here that implies 252 into, see, if I take one more 7, it will be 7 into 7. So, 7 is also getting paired here. Therefore, if I multiply this 252 by 7, I am going to get a new number that will become a perfect square. Okay, 252 into 7. Let us see. So, it is 7 2s are, yes, it is 14. 7 5s are, it is 35 plus 1, 36. Yes, 7 2s are, it is 14. 14 plus 3. Yes, of course, it is 17. 1764. So, now what it will be? It is equals to, it is 2 into 2 into 3 into 3 into 7 into 7. Are they both same? See, I have multiplied 7 by this number. That is nothing but multiply 7 both the sides. Into 7, here into 7. So, both the answers will be same. Now, 2, 3, 7. So, 1764, square root of 1764 is equals to 2 into 3 into 7. What is that answer? 2 3s are, yes, 2 3s are 6. Yes, 6 7s are, yes, of course, the answer you are going to get, it is 1764. That is 42 is the answer. It is ending with 2. Therefore, the square of number which ends with 2 is 4. Yes, you got the answer. So, in this way, you have to find the answer for all the questions given in the exercise. I am going to take one more number. Yes, let us find it. The next number will take it as 2352. 2352. Is 2352 a perfect square? It is not a perfect square because it is ending with 2. Okay. So, now with this heading, whenever the numbers are given, these numbers are not perfect squares. These are non-perfect squares. Okay. So, 2352, it's being non-perfect square, we need to find a smallest whole number by which it should be multiplied to get a perfect square. Okay, I'll do it. So, by using which method? Yes, of course, prime factorization method. 2352, it is divisible by 2. So, the factors 2 1s are, yes, 2 1s are 2, 2 7s are, yes, 2 6 are. Yes, see, 2 1s are 2, 1 left, 15, 2 7s are 14, 1. So, it is 2 6s are 12. Still it is divisible by 2, 2 5s are 10. So, 17, 2 8s are 16, 1 left, again 2 8s are. Yes, still it is divisible by 2, 2 2s are 4, 1. So, 2 9s are 2 4s are. Yes, 2 1s are 2 4s are 8, 1 left, 2 7s are. See, 147 is there, it is not divisible by 2. So, the next smallest prime number is what? It is 3. Okay. 7 4 11, 11 plus 1 12, therefore, 147 is divisible by 3. Divisibility rules we have to use. 7 4 11, 11 plus 1 12, 12 is divisible by 3. Therefore, 147 is divisible by 3. 3 4s are 12, 2 left, 27, 3 9s are 27. Then, is it divisible by 3 now? 9, 4, it is 13, it is not divisible by 3. So the next prime number is 5, it is not divisible by 5. Then you have to go for 7, 7, 7s are 49, so 7 1s are 7. Yes, over. So now if you observe the vertical column, you will find that 3 is unpaired. Okay. Therefore, 2352 is equals to 2 into 2 into 2 into 2 into 3 into 7 into 7. Okay. So here it is confirmed that 3 is unpaired, right? Here 3 is unpaired. Is not paired or unpaired, only one word you have to use. Here 3 is unpaired. Therefore, 2352 should be multiplied by 3 to get a perfect square. Yes. Therefore, 2352 should be multiplied. It should be multiplied by 3 to get a perfect square. Okay. PS I wrote, it is perfect square, but you write it as perfect square. Okay. So 2352 should be multiplied by 3. That implies 2352 into 3. Yes, because it should be multiplied by 3. Then that is nothing but on both the sides we have to multiply. Yes, it is 3 into 3 into 7 into 7. What the change you are observing here? On both the sides we have multiplied by 3 to get a perfect square. Okay. So now it is 2, 2, 3, 7. Okay. So 3 2s are 6, 3 5s are, it is 15, 3 3s are, it is 9 plus 1, 10, 3 2s are 6 plus 1, 7. That is equals to. So you can write it as square root of 7056. It is 2 into 2 into 3 into 7. Directly I wrote here because all this we have learned in last 2 videos, isn't it? It is 2 square, 2 square, 3 square, 7 square. That square is shifted this side, it has become square root. So it is 2 into 2 into 3 into 7. So what is the answer? 2 2s are, it is 4, 4 3s are 12, 12 7s are 84. Yes. So square root of 7056 is equals to 84. We have found that by which it should be multiplied. It should be multiplied by 3 to get a perfect square, and also find the square root of the new number. The new number what we got is 7056. Therefore, square root of 7056 is 84. Okay. I hope you all have understood this, and this is the way how to answer for these questions. Yes. When it should be multiplied. Okay, so this is the process. It carries 3 marks. Some other problems are there, some other numbers are there, many numbers are there, however, those are not perfect squares. Okay, so in this way only you have to solve. It carries 3 marks. Getting? Okay. So now let us take the next sub question, that is find the smallest whole number by which the following numbers can be or must be divided. Yes. Find the smallest whole number by which the following numbers can be divided to get a perfect square, and also find the square root of the new number. Okay. So here both are same. Here also we are going to take, what we are going to take? We are going to solve the prime factorization. We are going to find the square root of that number by using prime factorization method only. But here the given numbers are not perfect squares. Yes, we know that already. Now, here also we are going to get that the numbers are unpaired. The numbers are unpaired. If you multiply, if you divide, sorry, it is divided. If you divide some whole number by the given number, yes, okay, the given number should be divided by some whole number to make it a perfect square. Yes, I'll make you understand. We'll take the number 396. Yes, is 396 a perfect square? See, is it a perfect square? It is not a perfect square. Why? Why it is not perfect square? You should not say that it is ending with 6, it is not a perfect square. The number which ends with 6 may be perfect squares. Yes, we know that already. It is not perfect square, I am 100% sure, because the nearest perfect square of 396 is 400. Therefore, it is damn sure that 396 is not a perfect square, because 20 square is what? 20 square is 400, 19 square is 361, therefore 396 is not a perfect square. Yes, so now let us find the square root, let us find it by using prime factorization method. 396 is there. Is it divisible by 2? Yes, of course. 2 ones are 2, 1 left, 2 nines are 18, 2 eights are 16. Yes. 2 nines are, yes. Then 3 33s are, 3 11s are, yes, it is 11 ones are. See, 11 ones are 11, 3 11s are 33, 3 33s are 99, 2 99s are 198, 2 198s are 396. Okay, so now, therefore, yes, therefore, 396 is equals to 2 into 2 into 3 into 3 into 11. Observe carefully, 2 into 2 into 3 into 3 into 11. Here if you observe, which one is unpaired here? 11 is unpaired. Yes. The question is, find the smallest whole number by which the following numbers can be divided. 396 can be divided by some smallest whole number to make it a perfect square. Now, if I remove this 11 from here, remove in the sense we are going to divide on both the sides by 11, so 11 will be cancelled. What left now? 2 into 2 into 3 into 3 will be there. Yes. If you divide both sides, you are going to get the answer where LHS will be equal to RHS. Then the number what you are going to get is the perfect square. Yes, I will do it. Here 11 is unpaired. Yes, see the way how I am writing. Here 11 is unpaired. Therefore, 396 should be divided. It should be divided by 11 to get or to make a perfect square. Yes, that is nothing but 396 divided by, yes, 11 is equals to, it is 2 into 2 into 3 into 3 into 11, divide both sides, we are saying, right, divide it by 11. Okay, so when you divide, 11 gets cancelled here. Yes, but we can't cancel here. Now see, it is what? The answer still we don't know. Yes, we can get the answer. Now it is what? It is 2 into 3. Why I have considered 2 into 3? Here I am going to get some number which is a perfect square. It is sure, because here 11 is removed. What left? 2 and 3 are paired. 2 3s are 6. Yes. So, what is the square of 6 then? Yes, of course it is 36. Yes. Here if you divide it, 11 3s are, yes, 11 3s are 33. Okay, 11 3s are 33. So here you are going to get then 66. 66, 11 6s are, yes, see, 11 3s are 33, 6 will remain, 6 means is 66, 11 how much are 66? 11 6 are 66. So no need to worry about this. However, you are going to get the answer in a simplest way. So it is 2 into 3 is root 36. Okay. So which is the new number? Find the square root. The new number is what? Yes, it is 36. Okay. So by which it should be divided? it should be divided by the number which is unpaired. Are you getting? Yes. So now we will take one more number and then you will understand it clearly. Okay. So the next number is, sorry, I hope you are understanding this one. Yes? Okay. So the next number, we consider it as 9408. Find the smallest whole number by which 9408 should be divided to get a perfect square. Yes? 9408 is there? Yes, of course, it is not a perfect square. Why it is not a perfect square? It is ending with 8. Okay. So now, yes, let us go for prime factorization method. 2 4s are 8, 2 7s are 0 as it is, 2 4s are. Yes. 2 2s are, 2 3s are, 2 5s are, 2s are. Yes. 2 1s are, 1s are, 7s are, 6s are. Are you getting? 2 1s are, 2 1s are, 1 left 15, 2 7s are 14, 1 left, 2 6 are 12. Then 2 5s are 10, it is 17, so 2 8s are 16, 1 2 8s are. Yes. 2 2s are, yes, 1 left, 2 9s are 18, 2 4s are, 2 1s are, 2 4s are, 2 7s are. Yes. You two have to do like this only. 2 1s are, 2 4s are 8, 2 7s are. Now it is not divisible by 2, but it is divisible by 3. The same, yes. Now 3 4s are 12, 2 left, 9s are 7, 7s are 7, 1s are. So which is unpaired here? Yes, of course, 2 2 2 7, 3 is unpaired. Okay. Therefore, directly also you can write, or 9408 is equals to 6. Yes, 2 is for 6 times. I will write it. Yes, don't forget to express the numbers which are in the vertical column here. And also one more thing what I observed is, here how many 2's are there? 6 are there. While watching, you will think that there are 6 numbers, and while writing here, you will write it as 5 2's. Yes, you will miss 1 2, but here 6 are there, here you are writing 5. So observe carefully and write. Okay. So it is 1 2 3, then it is 3 into 7 into 7. Okay. Here 3 is unpaired. Yes, here 3 is unpaired. Therefore, 9408 should be divided by what? It should be divided by 3. One more thing keep in mind, that sometimes you people will write that when compared with 3, 2 is the smallest number. Yes, of course it is, 2 is smallest, but which is unpaired here? 3 is unpaired. Don't write the smallest number is 2 here. It is not. Which one is unpaired? That should be multiplied by the given number. Yes, 9408 should be, here it is divided and there it was multiplied. Should be divided by 3 to get a perfect square. Okay. So that is nothing but 9408 divided by 3. Yes, that is equals to 2 into 2. Yes, it is for 6 times. I will write as it is. Into, I will write 7 into 7 into 3 whole divided by 3. Yes, whole divided by 3. 3 3 gets cancelled. Then what will be left? See here. That is nothing but 2 into 2 into 2 into 7. Why not 3? 3 and 3 are getting cancelled. Are you getting? So 2 into 2 into 2 into 7. So what is the answer? 2 2s are 4. 4 2s are 8. Yes, 2 cube it is 8. 8 7s are, yes, 56. So 56 here you are going to get, then this answer is left to you. So, this answer you need to write here. Then what is that answer? Divide it, you will get 3 3s are, yes, 3 3s are 9, then 3 1s are 3, 1 left 10, 3 3s are 9, 3 how much are 18? 3 6 are 18. So, square root of 3136 is equals to 56. The number is ending with 6, therefore, the square of this number ends with 6. Okay? I hope you all have understood all these topics. Yes. So, these are the 5th or the 6th main questions in your 5.3 exercise. Solve all those problems. Yes. All these will be there for your monthly test, that is on 1st of next month, that is October. Okay. Then, and some more things I want to clear in the last exercises. Yes, there were some questions like, yes, I will write it on the board and then you will understand. By watching or by observing the last digit of a number, write the square of the given number. What is that? By observing the last digit of the given number, write the square of that number or write the digit of the square of that number. See. If it is given 14 is there, yes, what is the square of this number? The square of this number is of course 196. What is the unit digit of the square of the given number? What is the unit digit of square of the given number? The unit digit of the square of the given number is what? It is 6. See, unit digit of the following is, unit digit of the following is what? 14. Yes, of course it is 6, because the number is ending with 4, its square ends with 6 because it is 196. If it is 293 is there, still I don't know what is the square of 293, but I can say that the square of this number ends with 9. Yes, because it is ending with 3, its square ends with 9. Then, if it is 127, it is ending with 7, therefore, its square ends with 9. Yes, if it is 51, yes, its square ends with 1. If it is 79, it is ends with 1. If it is 34, yes, 4 square, yes, it ends with 6. If it is 328, it is ending with 8, therefore its square ends with 4. 8 8 is 64. Yes, like this if you write, that will be well and good. Don't use equal sign here, because 14 is not equal to 6, 243 is not equal to 9. Use arrow mark, otherwise for all the answers you need to write this. The unit digit of the following is 6, the unit digit of the 293 is 9. No need to write all those things, only one heading is enough. Okay, and some more questions are there. By observing the last digit of a given number, write whether the given number is a perfect square or not, isn't it? By observing the last digit of a number, write whether the given number is a perfect square or not. Yes, we know that if the numbers are ending with 0, 1, 4, 5, 6, 9, those may be perfect squares. Yes, but the numbers which are ending with 2, 3, 8, these are not perfect squares. That we know already. Yes, let us say, if it is given as 32, is 32 a perfect square? By observing the last digit, the question is what? By observing the last digit is 2. Is it a perfect square? 32 is not a perfect square because it is ending with ending with 2 over, then if you take another number, if it is 130, 130 is there, is this 130 a perfect square? Is it a perfect square? As I observed, you people wrote it as 130 is not a perfect square because it is ending with 0. Is it correct then? Because it is ending with 0, therefore it is not a perfect square. Can we say that? No, we can't say that, because we know that 100 is a perfect square which is ending with 0. Yes. So, if you observe these two, it is also ending with 0 and this is also ending with 0, then how can you say that the number is ending with 0? It is not a perfect square. We know if a number ends with even number of zeros, then it is a perfect square. It may be a perfect square, but the number which ends with odd number of zeros is not a perfect square. Okay. Here 130 is not a perfect square because it is ending with 1 0. Yes, it is ending with only 1 0 or single 0. Yes, or see here you can use it is ending with only 1 0, it is ending with single 0, or it is ending with odd number of zeros. Okay. If the number is what? If it is 83. Is 83 a perfect square? 83 is not a perfect square because it is ending with 3. Yes, are you getting? Yes, so such questions are there in your exercise. And also, as I saw your fair books, those who have sent to me, there I observed that still you are making mistakes. How I am solving on the board? Like that only if you solve, that will be the easiest method. Yes, and some other easiest method you people are following, and I am happy that most of the people have sent me the video about telling the squares of numbers, and I have seen some students are telling the squares up to 50. I am very happy. Learn all those things. Yes. Okay. So your tests start from first, second and third. Read well for that. Yes, if you have any doubts, you can call me, all the teachers anytime. Yes, and try to bring your fair book to the school and get it corrected whenever it is possible. Yes, thank you.